So this is the third day of section 5.3, solving trig equations. And this section introduces some more complexity in solving trig equations. So the first thing that we need to tackle is extraneous solutions. We've seen extraneous solutions before, excuse me, when we are solving, maybe log equations or exponential equations and the like. So let's take a look at the example that we have here, where we want to solve cosine x plus 1 equals sine x in the interval 0 to 2 pi, not including 2 pi. Now this one's really hard to see which is the way to attack. The problems here will probably rely on knowing some identities. Excuse me. So I think the first thing that I'm going to do is I'm going to square both sides. So I get cosine x plus 1 quantity squared equals sine squared x. The reason why I do this is I'm familiar with identities like sine squared x plus cosine squared x equals 1. And so I want to try and generate sine squared x and cosine squared x so that I can do something with it. So if I now expand the left, I just fold that out, I get cosine squared x plus 2 cosine x plus 1 equals sine squared x. So now I'm going to replace sine squared x with 1 minus cosine squared x, okay, using the what I've called the famous pickup identity. All right. And if I move the cosine squared over to the left, so move that over like that. Oops. Okay, whatever. Move it over like that, so that becomes 2 cosine squared x plus 2 cosine x, and this one cancel to give me a 0. And then I can divide by 2, and I get cosine squared x plus cosine x equals 0. And I can factor now, and I get cosine x equals cosine x plus 1, which is 0. So we've seen how to solve this equation previously, okay, on the very first day of 5.3. Using the zero product property, okay? So I get cosine x equals 0, from which my solution would be x equals pi over 2 or 3 pi over 2. And from the other one, I get cosine x equals -1, for which x equals pi. Okay? All right, so we've got 3 potential answers here, and obviously the hint in the notes here tells you extraneous solutions. So obviously I got to be on the lookout for extraneous solutions. Do all these solutions work for the equation that was given to us before we squared it? Okay, not after we squared it, but before we squared it. In other words, do these solutions here work for this equation here? So if you put pi over 2, okay, then I know that cosine, so I'm going to check. Let me go bring another notepad up here, and I'm going to do it in here. So what I'm doing is I'm taking pi over 2 and stuffing it in here for x in this equation here, okay? So I get cosine pi over 2 plus 1, and cosine pi over 2 is 0, so that gives me 1, and sine pi over 2 is also equal to 1, so that pi over 2 seems to work okay. All right. Let's see if 3 pi over 2 works. So I have cosine 3 pi over 2 plus 1, okay, is equal to 0 plus 1, which is equal to 1, because cosine 3 pi over 2 is 0. On the other side, I have sine 3 pi over 2. Well, sine 3 pi over 2 is -1. So these are clearly not equal to each other, and therefore 3 pi over 2 is an extraneous solution. Okay, so you need to cross this out and say that it is extraneous. Okay, so please make sure you make that statement that it is extraneous. How about putting in x equals pi? So cosine pi plus 1. Cosine pi is -1, so -1 plus 1 equals 0. And sine pi is equal to 0. So pi seems to work. So that solution is right. This one's right, and so is this. This one is extraneous. Okay? So you're going to learn how to check for extraneous solutions, okay? All right. Okay, this topic now of multiple angles introduces a fair amount of complexity because you can get many answers. So stay with me and see what we need to do, okay? So first of all, the difference between multiple and not multiple. So the example I have here, example 1, is not a multiple angle because there is no number in front of this variable phi. Phi is the variable angle that we want to solve for. There is no number in front of it, or the number in front of it is just 1. Okay, whereas here the number in front of phi is 3, and that's why this equation here is called a multiple angle trig equation. And you're going to get lots of solutions out of this. Okay, you're going to get lots of solutions out of this. So you could be very careful and be thorough and meticulous about how you do this. Okay. All right, let's see which problem I'm going to solve. Actually, why don't we go ahead and do this one? Let's go ahead and solve this equation, example 2. Okay, let me get my notepads out. Close that. Close that. Get a new one out here, and I'm going to solve the equation 2 cosine 3 phi minus 1 equals 0. Okay, that's what I want to do. I want to solve this 2 cosine 3 phi minus 1 equals 0. Okay, so the first thing I'm going to do is move the 1 over, and I get 2 cosine 3 phi equals 1, cosine 3 phi equals a half. Now, we've seen problems like this before, okay, and half is a friendly number, so you need to know your friends table. I keep telling you that over and over again. You've got to know your friends. The only trick here is that the angle we are talking about